All right, everyone, I'm very excited to introduce Professor Peter Ganong. He is an economist who studies the effects of public policy on people facing difficult financial circumstances. In his research on the foreclosure crisis, he found that most borrowers defaulted due to insufficient liquidity and that many foreclosures could have been averted through liquidity-focused modifications to mortgages. He also has found that unemployment benefits play a crucial role in sustaining the consumption of unemployed workers. In ongoing work, he is studying the effects of racial wealth inequality and the effects of high liquidity on the US economy. Professor Ganong is a faculty research fellow at the National Bureau of Economic Research. He received his BA and PhD in economics from Harvard, and he has spent 2 years in public service, one at the White House Council of Economic Advisors and one at the City of Boston Citywide Analytics Team. He's taught at the University of Chicago since 2017 and was a visiting assistant professor at MIT during the fall of 2021. Professor, I'll hand it over to you.
Thanks. Hi, everyone. Good afternoon. I'm Professor Peter Ganong. I want to strongly encourage you, if you can, to turn on your camera. Both, it just makes it a little easier for me to sort of see how you're reacting and thinking. And also, there's going to be this is going to be a relatively participatory. It's not exactly a lecture. You'll see. So one of the hats that I wear at the Harris School is I'm I don't know what the title is, something in charge of the data analytics certificate. And this is a set of courses that came out of my time. I was in my PhD in economics and I didn't like it. And I took a year off and I worked for the city of Boston, helping them to set up their analytics team. And then I basically, once I came to the Harris School, wanted to put together a set of courses that would help other people fill similar roles in the future. So I'm going to talk for 2 minutes about what is the data analytics certificate, and then I'm going to do an excerpt from lecture 1 of the first class in the data analytics certificate. So the certificate is designed for beginners, and by the time you graduate, if you do the certificate, you'll be able to autonomously analyze data and visualize patterns. And this is not easy at all. So it requires a really substantial time investment. There are 3 required courses, and it's 10 to 20 hours a week for each course. And so people always say these are the hardest courses they take at Harris, and we're well aware of that, and we're totally okay with that. It's equivalent over doing 3 quarter-long courses that are each 10 to 20 hours a week to if you signed up for a data science boot camp that would be probably 50 hours a week and last maybe 12 weeks. So it's sort of similar in cost and similar in time to doing boot camp, but it's a boot camp that's inside of the MPP. There's a ton of, much like a boot camp, there's a ton of hands-on help. So in the intro class, we run in-person labs, and we have active message boards, and we have a whole infrastructure to answer questions. You can do the whole certificate in either Python or R, but you only do one of the 2. And the reason is because we really want you to gain fluency. Once you gain fluency in one language, it's much easier to translate to other languages. But if you do a tiny bit of several languages, you sort of end up with not as much. One other thing, just if you're sort of like trying to figure out your way around Harris and different paths at Harris, the certificate is voluntary. You don't have to do it to do the MPP. And so it's a lot more coding time than if you just do the required courses in the MPP. But it's also less coding time than if you do the MS CAP, which is sort of a 2-year program. And so this is sort of like an intermediate of if you want to do the MPP, but you also want to learn how to code. With that, so I teach in Data and Programming 1. I teach in the R track of Data and Programming 1. And so I am going to now, I'm going to basically teach an excerpt from the very first class from lecture 1. The class has like 12 lecture notes that spread out over, I don't know, 16 sessions or something. Can everyone see the screen share that I'm sharing right now? Okay.
Yes.
Okay, so the way that all of lecture 1 is designed, and I can, Jenny, I can send you these slides afterward so that you can send them around the PDF if you want, if stuff goes by too fast or whatever. I'll just make myself a note to make sure to send them to Jenny. So we ask a set of questions, and then we talk about what are the queries that you would ask the computer, specifically ggplot, to do in order to answer those questions. So one very simple question, we have this data set on cars. It's not particularly interesting. It's just the very first data set that is in the textbook. And so on the x-axis, I've plotted the size of the engine of the car. And on the y-axis, I've plotted highway miles per gallon, which is a measure of fuel efficiency. Again, this is like not an intrinsically interesting public policy thing. This is like the very first data set. And so we asked a simple question: how does engine size affect fuel efficiency? So I would love to hear from someone. I guess raise your hand because I don't know your names yet, but I can call on someone. How does engine size affect fuel efficiency? Grace, it looks like maybe you're talking, but I don't see you. Here. Wait, here, do it again. Try it again.
Yeah, it looks like the smaller engine size is better. It's at
Great.
the yeah.
So smaller engines are more efficient.
Sure.
And then do you notice any exceptions to that broad pattern?
Yeah, let's see. I haven't done this in a while. You've got the 4 liters. Okay. I mean, well, yeah, you have the 2 dots in the bottom. So on the far hand side by the 2.
The 2 dots where?
Yeah, the 2. So straight up from where you are. Yeah.
Great. So there's 2 outliers that are more efficient than all the other cars. What else stands out? I'm going to go to someone else now. To someone else. Jenny, can you just give everyone permission to unmute if that doesn't wreak too much havoc? Jenny, here, I can unmute you.
Yeah, sure. Looks like I'm able to unmute, no problem. It sort of seems like it's trending down, but by about like 5, the engine size being like 5, 6, 7, there's like a very interesting kind of jump up again in efficiency.
So there's something going on here where these cars are more efficient, but they're also big. Damon, is there something else that jumped out to you? You say you're good. Okay. Great. So the outliers that stood out to me are the same ones that stood out to Jeremy. So and I'm skipping over some of the coding details here in the interest of sort of focusing on the ideas. So there are these dots up here that are cars that are big engines but still have good mileage. All I've done so far is just recolor dots. Does anyone have any theories?
I see we have a Zoom hand raised for Damon. I think everyone should be able to unmute themselves now and use the chat as well.
Does anyone have any other guesses?
Alternative fuel.
Alternative fuel. Okay.
I see Belgica, I'm sorry if I'm pronouncing your name wrong, mentioned in the chat, hybrid, I think in response to this question.
Hybrids, okay. Although hybrids don't necessarily have big engines.
Suzanne in the chat mentioned car design.
Car design, okay. One thing is it's a little hard to teach and monitor chat. I learned from like, I don't know, 2020 and 21. So I'm not going to watch the chat. I encourage you to unmute, but it's too hard to like watch the chat.
So the other thing I know that happens is in some luxury cars, they do things to lighten the car. Like they don't include, they'll opt out of putting a spare, a full spare, or even any spare, as opposed to just offering service, like 24-hour service. So that may account for that as well.
Cool.
Juliet.
Oh, go ahead. Sorry, Juliet.
Oh, I was going to say diesel versus gasoline.
Diesel. Okay. And then one other person, I couldn't quite see who, was a little hard on Zoom, but one other person chimed in with an idea.
So some of them have like sport mode, comfort mode, and eco mode.
Great. So in this case, that last answer from Belgica, am I saying it?
Yes.
Okay. So this is a case where like there's an outlier and you want to understand what's going on and you see it in the plot and you want to investigate it further. In this case, usually there's not a simple, easy answer, but in this like toy classroom example, there is. So what we're going to do is we're going to change the query that we're using to illustrate the plot to have different colors for different dots by car class. So car class here is now going to go from SUV, pickup, minivan. And you can see that almost all of those cars that we were interested in are two-seaters. So this is kind of related to Belhika's point about sport mode, but it's like an entire sports car is what the two-seater is. And so this was one where it was really easy to use a specific software tool to answer the question, why do some cars have big engines and good mileage? Because there's one variable, which is, are you a sports car or not, that explains everything about being an outlier. This is like what I'm going to now skip over a little bit more of the syntax that we cover in class. Not that we skip it in actual class, but here I'm just trying to cover sort of the conceptual parts. So another question you could ask about this CARS data set is fuel efficiency rising? And the way that I'm going to try to answer that question as a first pass is I'm going to add another argument to geom point, which is factor year. And when I add factor as a year, all of the circles are going to capture cars that were made in 1999. And all of the triangles are going to capture cars that were made in 2008. Now, I'm going to ask a question here where I don't even really need participation to answer because it's going to be obvious. Is it easy to tell is fuel efficiency rising from this plot? The answer is no. It's actually quite hard, at least for me, because I have to squint a lot to figure out what's a circle and what's a triangle. And my eye is mostly focused on the differences in color, which are not the important thing for if the research question is fuel efficiency rising? So what I'm going to do instead is instead of having year as a shape, which makes it pretty hard to read the question, I'm going to instead include year as a facet. So a facet here is the way that ggplot talks about different panels. So all the 1999 cars are in the left facet, and all the 2008 cars are in the right facet. So now, is fuel efficiency rising? What do you interpret based on this plot?
No, it's not.
And why are you able to read it off of this version of the plot, even though you weren't able to read it off the other version of the plot, Naomi?
Comparing them side to side, I think gives a good visualization of where the majority of the dots are a little bit easier.
Great. So you can almost imagine here. Let's see. I have not taught on Zoom in a while, but you can almost imagine that like you can see where the 2008 line would have been once we separate them out and put them in separate panels. So that's exactly right. Here, let me erase this. Okay. So faceting is one way to draw out the answer more clearly, as opposed to adding as a shape, which is a less clear way to get the answer. But we can do even better.
Excuse me.
Please, go ahead.
So is the question about why larger car engines get better fuel efficiency or fuel efficiency in general?
Great. So I did something sneaky, which I'm glad that you called out because it's actually really useful. I switched the research question from tell me about engine size and mileage, for which a scatter plot is a really natural way to get at it, to is fuel efficiency rising? But like, why am I even using a scatter plot? Like, it's not, I could have just used a bar plot with average fuel efficiency in 1999 and 2008. And so like part of what I try to convey in the course and I'm trying to convey now is like, you actually want to custom tailor the plot you make, not to have all the information in the world that looks pretty and is interesting, but to answer specifically the question that the readers is interested in. And so I changed the question, but I didn't change the plot type, and that was kind of sneaky. And I could have just used a bar plot with 2 lines to provide like the most direct answer to the question. Now, if I were to like take the other side and defend this current plotting structure, what I would say instead is that there are technological improvements. So I'm going to switch now away from dropping these colors for different car classes, because that's pretty distracting, and just do one color by each year. And now you can see pretty clearly, yeah, fuel efficiency is rising. It's higher in 2008 than 1999. However, the other thing you can see is that there's a lot of dispersion in car type. In like, I guess I should be more specific. There's dispersion in engine size. And it's sort of like there's been, for the most part, like a technological shift where almost every car that's made in 2008 is better than the car of the same size that was made in 1999. If I only had showed you just the bar plot, that's not something you would have taken away. But by doing it this way, I can give you this extra information. Now, does this information help you as a reader? I don't know. That depends on what you want your reader to take away. Do you have a follow-up, Damon? That was a very good question. So I want to make sure it's responsive.
No. I mean, I'll save it. Just continue.
Great. Okay, so I've got into a CRISPR plot answering the question, is fuel efficiency rising, with two different colors. Jeremy.
Yep, sorry about that. I just wanted to ask really quickly, what is dispersion? Would you mind explaining that in this context?
There's two notions of dispersion. One is that there's a range of different engine sizes. That's the DISPL variable. And then another is, even at a single engine size, you know, we talked before about the 2-liter cars, some cars will be more and less efficient for some other reason. So those are like two different, I don't remember which way I used it the first time, but those are two like different notions of dispersion.
Gotcha. Thank you.
Great. So I sort of already said all these ideas in response to Damon's prior question. We'll say them very briefly. One question you can ask is, how does engine size affect fuel efficiency? That's an example of the question, how does X affect Y? And the right tool for that is called geome point. And the answer you get from that plot is that larger engines are less efficient usually. However, this naturally gives rise to a follow-up question. Why do some cars have big engines and good mileage? And that's a specific example of a very common question. What's going on with these outliers? So we use two different tools, both color and facet wrap, and we saw a very clear answer. It's the 2-seaters that are the big engines that are also fuel efficient. You know, like Damon talked about them not carrying around an extra tire. They're literally not carrying around extra people. It's just another version of the same point. And then we finally asked a different question. Is fuel efficiency rising over time? It's a version of the general question, is why changing over time? And we used one tool, color, to answer that question. And so the sort of key idea that I want you to take away from this subsection of the lecture is that given the exact same data set, you will answer different questions with different plots depending on what is the message that you most want to emphasize. Any questions? Okay, so I'm going to do one more subsection of the lecture. So we do it. The whole lecture is all around just all the different plots you can make with a single data set. So I'm going to go back and revisit the question that we asked before. How does engine size affect fuel efficiency? And here I'm going to have, you can see, I'm going to give ggplot exactly the same data set. This is the function call for the left panel. This is the function call for the right panel. And I'm going to give it the same X and Y variable, but I'm going to give it a different geome. And so in the left panel, this is the scatter plot, geome point you saw before. And then this is a new geome, which you haven't seen before, called geome smooth. So what geome smooth does under the hood is it runs a local linear regression to compute what's the average value of fuel efficiency at every engine size. And what you can see is that it's going down, just like we talked about. And you can actually see that pattern more clearly if I just show you the right panel instead of the left panel. And then it actually goes up in the right tail, again, driven by those sports cars. I can also overlay these two geomes on each other. And then you can see both the dots, and you can also see the local linear regression. So at this point in the class, what I do, and I do this actually in every single lecture, is I do a do pair share exercise. So by a do pair share exercise, what I mean is I ask you to code something up on your own, and usually set a timer for about 5 minutes. And it's usually some variant of what we've been covering in class. Then after 5 minutes, we talk in pairs. So you talk to the person sitting next to you for another 2 minutes. So here's what I coded up, here's what I coded up, here's how it's different. And then we come back together as a whole class and share. And so obviously I'm not going to ask you to do the do pair share exercise now because you aren't in the class yet, but this is a feature of every single lecture that I give. And I'm going to show you my answer. So this is my answer to the do pair share exercise, has fuel efficiency improved? And you can see that I'm calling two geoms. So I'm calling both geom smooth and geom point. I'm going to use different colors for the 2 years. I'm going to turn off standard errors. So you might remember before that there was this dark gray band around the local linear regression. I'm going to turn that off for my version of this plot. And finally, I'm going to set alpha to 0.25. That's going to make each individual dot a little bit hollow. And then something that we covered in a part of the lecture that I skipped, but I can explain now, is that if there's a dark dot, it means there's multiple cars at that point. Whereas if there's a light dot, it means there's just a single car at that point. So I've now made a plot which is my attempt to answer the question, has fuel efficiency improved? And I want to sort of throw back a version of this question to you, which is I want to ask, what are all of the lessons that you take away from this plot? And so there'll probably be many people will have different lessons that they want to take away. And so we'll just sort of go around for, again, sort of open participation. There are a lot of lessons, so don't be shy.
The lesson I take away would be I can have a big engine and still be fuel efficient.
Okay, if you get a sports car.
If I get a sports car, correct.
Great. What else?
No family.
We weren't necessarily that more fuel efficient. I guess as far as the sampling goes, there's some that are quite the opposite in 2008. So just because it doesn't mean it's necessarily improved.
Great. So 2008 cars are not always more fuel efficient than comparable 1999 cars. What else?
I think that due to the outliers, you can probably, some of the data is skewed, and therefore the averages are skewed as well. So if you sort of need to have both data sets to compare, because otherwise you may view the outliers as the average, which we see with the two-seater situation.
Wait, when you say both data sets, do you mean both geoms or do you mean both years? Both geoms.
Both geoms.
Okay.
Because otherwise, when you look at it, if you were just to look at the line, you would think, oh, this is really interesting. Larger cars can actually be quite efficient, but in reality, what's skewing that data are two-seater cars, but SUVs are still really inefficient.
Great. What else? What else stands out? Or what else can you learn beyond these 3 points from this version of the plot?
There's a little bit of a sweet spot. I don't know if that's the right term, but kind of there's that clump where all the clumps are. You can kind of see that, yeah, where you are, your arrow.
Like where the cursor is.
Yeah.
Here, I'll draw just to be more specific. Yeah, so there's actually a big chunk. We've never until now been able to see where most of the cars are, but actually like this is the most common car type. And I don't know, maybe this is also a very common car type. So the shading tells us something about the density of where engine sizes are more or less common, and let me just build on that for 1 second, Grace. So like the 2008 line tilts way, the regression line tilts way up, and the 1999 line doesn't tilt way up. And you might have thought, oh my gosh, there's a huge change. But once you see the dots, you say, okay, actually, there's only 3 cars here that are driving everything. What else? So one thing about my class is there's always a lot of awkward silences because like I put a big premium on class participation, and some people like think really quickly and some people need time to digest. And so like I have no fear at all of awkward silences because like I really value class participation.
I think efficiency is improved because green
yes,
line.
Thank you.
Yeah.
That's the headline question. I asked, has fuel efficiency improved? That's the most important thing. Yes, fuel efficiency has improved.
Because green line is above the red line.
Yep. And it's above the red line everywhere, in fact. So it's at every place fuel efficiency has improved. Great. So now I'm going to show you I tried to do this exercise myself before asking you to do it in a participatory fashion. So Takushi had, the headline answer, yes. One thing about this plot that is deliberate but worth noting is that many good plots will have both a headline message and a sub message. So the headline is, what's the first thing that jumps out at you, right? I'm flipping through, I flip through, is fuel efficiency higher? It would be slightly better if I had written 2008 right here and 1999 right here instead of putting the factors here. But the first thing your eye sees is the line, and it's above, the blue line is above the red line at every point. You can just answer that question right away, yes. However, there's actually a bunch of sub messages once you spend more time staring at the plot. So the small engines have an improvement in fuel efficiency. The middle-sized engines actually don't. There's some more efficient engines that were invented in 2008. Engine size is not a perfect predictor of efficiency. So Grace made this point. And relatedly, there's some 1999 cars that are more efficient than the 2008 comparables. So you had other lessons beyond that. So in particular, the engine size not a perfect predictor is more or less what Arthur said. And some 1999 cars is more what Grace said. And then Jeremy's point is true, but it's not even in this list of sub messages. So you can get a lot out of staring at a plot for a really long time. And basically, like, we do a lot of this in my class of staring at a plot and trying to draw out what are all the different things that you can learn from it and what are the lessons that we emphasize and not emphasize. So I'm going to skip this. So there's another instructor in the data certificate whose name he goes by his last name Bowie, and he teaches a data viz class which is basically open to you if you first have taken the certificate, the other classes in the certificate. And this is like his side hustle. Like his main job is he works at the New York Times Upshot, and his motto is make dozens of plots. And so anytime he makes a plot that goes on the website or in the newspaper, he's made a huge number of plots before. And what does he mean? The first plot you make will never be the one you end up showing to someone else. As a rule of thumb, you should try out at least 3 different plotting concepts. And in the language of ggplot, that's try out 3 different geomes to convey your point. And then within each concept, you'll need to try out several permutations. So I'm going to stop with, this is like a half an hour out of a 90-minute lecture, jumping around a little bit. And now I'm going to just open up for any questions you might have, either questions about the lecture or questions about the class or questions about the data analytics certificate more generally. I'm really happy to tackle any of those. I'm not going to watch the chat though, so just unmute yourself or raise your hand and jump in, please. Damon, is your hand up because you have a question, or is it just up from before? Okay.
It's just up from before. I didn't even know I put it up. I'm sorry.
No worries. Angelos?
Thanks very much for this. I was just wondering if you could maybe describe how people who take your class take some of the lessons into other elements of the Harris School.
So I think they're useful for doing problem sets in other classes. The Harris School also has policy labs, which are sort of hands-on internships. And so students will often use the skills in the policy labs. Fundamentally, the goal of the certificate is not to be useful at the Harris School. It's to teach you useful skills for after the Harris School. So many people who do the certificate will go into jobs as analysts with hands-on coding responsibilities. The other two things I'll say, just from like the alumni who keep in touch, is that who I therefore know what they're up to. I love it when alumni keep in touch. That's an aside. But one thing is basically, it's really hard to be a good participant in conversations about how your organization is using data unless you have experience coding against data yourself. And then the second thing is, like, often I've noticed, like, a couple years later, they're often managing a team of analysts, but you can't manage analysts effectively if you haven't written code yourself. So some people want to and become full-time coders. That's not the most common outcome, but you have to be sort of totally self-sufficient and productive in order to be effective in this as a leader in this space. Grace.
So I'm familiar with Tableau. I did a certification. That doesn't mean I use it every day. But I wondered, like, so can this complement that, the coding aspect? I know people use Python for certain things, for Power BI and for data extraction, but I just wondered how they work together and if you ever bring that up in class.
So there's some other classes that do Tableau at Harris. Basically, I think Tableau is a substitute for coding, and it has strengths and weaknesses. So coding is always going to be more flexible, and that's a reason to want to know how to code. The other thing is that because Tableau is just writing code for you in the background, it can actually be really difficult to understand what Tableau is doing. Like, there's sort of like once you understand, like, it's a similar thing actually with like Git, with like using Git at the command line versus using version control like GitHub Desktop. Like, if you don't understand what the guts are doing, it can be challenging to use the more graphical tools in a very sophisticated way.
Thank you.
I've actually got a question, if that's all right.
Great. I'm going to go to Greece just because I'm going to do the hand raising, and then we'll go to you next, Arthur.
I was just wondering, in regards to people who end up taking career paths in the data analytics sphere, how different you would say career outcomes are for people who do the MS-CAP program versus the MPP and data analytics certificate? Or do you think it's more about like what you put your work into and what experiences you have, or will those degrees really make a big difference?
Great. So if you want to learn how to code for the public sector, and that is your primary goal in going to the Harris School, you should do CAP, because it's more time and more exposure and more skills, and you'll just learn more of it. If you want to learn some about how to code and do some more of the like policy-oriented classes or history-oriented classes, then this is a better option. So it sort of depends on like what your interests are, or how sure or unsure you are. Arthur.
Grace nailed it on the head. I was going to ask the same thing.
Other questions? No one has any questions. This is not credible at all. Okay, Jeremy.
Yeah, so we talked a little bit about how, post the master's programs, going into the kind of workforce, how this might help. Would you be able to argue that this could be helpful for pursuing a PhD either at U Chicago or elsewhere? Would this sort of curriculum be supplemental for something like that track?
Great, so probably not. Let me say a little bit more. So there's a program, I'm forgetting the acronym, like I'm gonna brain fart. Jenny, feel free to jump in. We have a program specifically for people who want to do a PhD.
MACRM.
Yeah.
Yes.
So yeah, so
Go ahead.
I like, I occasionally get asked, is this good training for a PhD? And the answer is like, that's not at all what we're solving for. And in fact, it's like, this course is in some sense a reaction to other courses where professors often try to teach like a simpler version of their PhD course to master's students. Like, that's not what this is for. Like, this course is for public sector impact, and public sector impact through code and data analytics. So like one slightly related point is there is no statistics like anywhere in DNP1 or DNP2 at all. Like, there's a lot of code, there's a lot of data cleaning, there's a lot of viz. There's literally no statistics at all. Why? Because like my experience of working at the citywide analytics team was that statistics was not the most important skill. Like, I mean, I have a master's in statistics. Like, it's not like, I don't think it's interesting or fun, but like fundamentally, this is about training you to go back and work in the public sector or public sector adjacent places. And we have a different track if you are interested in doing a PhD.
That's helpful. Thank you.
I sent a link to the chat for everybody that goes to the career outcomes where you can explore like overall outcomes and MS CAP specific outcomes. And I also just sent the MACRM link there. And MACRM students are taking the same classes as PhD students. So there's very specific math requirements that we're looking for folks in that program. But we'll also do MS CAP and MACRM specific sessions after the application opens later in the fall. So know that there'll be lots of other information about that to help you kind of navigate the program that's a good fit for you and your outcomes.
More questions? Takushi?
Yes, I have a question. I heard that the topological data analysis is used to process for data analysis, and topological data analysis is used in policy analysis these days.
By topological, do you mean like maps?
Yeah, math.
Wait, math, M-A-T-H, or maps, like M-A-P-S?
M-A-T-H.
I'm sure, I'm confident it is used somewhere, but it's not part of the certificate.
Oh, okay. Thank you.
Grace?
So the follow-up question, and I think you might have already answered this, but it's 10 to 12 hours additional studies for the certification program in the data like field. That's part of it, but it's more than just what the classes we are taking already.
Sure. So sorry, let me explain exactly how I get that data point. So students are asked at the end of the quarter, how many hours a week did you spend on this class? Okay. So students say, I spent 20 hours a week on this class. I spent 10 hours a week on this class. Yeah. If you go to other courses, the numbers tend to be substantially lower than that. Mm-hmm. So it's not 10 to 20 additional, it's just, this course takes 10 to 20 hours a week, okay, as do the other courses in the sequence. And so it's pretty all consuming, and it's because like we're committed to being for beginners, and we're committed to ramping you up quickly to learn a lot of stuff.
Do you have a lot of students who are full-time employees also?
I don't think very many. I think there's some who are working part-time, but I can't think of many. Also, this is, as of now, I mean, this could change, but as of now, this is offered during the day rather than in the evening program. You know, we certainly like, enrollment in this set of courses is rising every year. So at some point, like we should have an evening section, but as of now, there's no evening section. Okay. Thanks so much, everyone. This was really fun. I hope to see some of you. I guess if you apply now, I'll see you in my class in spring 2024.
Thank you so much, Professor. Bye.
Thank you.